Let's solve the following differential equation. We begin by rewriting our differential equation in terms of dy over dx. So we will have dy over dx equals to x squared minus 3xy plus 2y squared divided by 2xy minus x squared. If we consider this to be equal to the function f of x comma y, and when we make a substitution x with lambda x and y with lambda y, then we will get back our original function f of x comma y. So this means that our function f of xy is a homogeneous function. Now because the function f of xy is homogeneous, this differential equation is going to be a homogeneous differential equation. Now the next step would be to solve this differential equation. However, we cannot use the method of variable separation here, because if we look at this function f of xy, in order to be able to use the variable separation method, it has to be the product of two functions where one is entirely a function of x and the other is entirely a function of y. Meaning, let's say f of xy should be expressible as a product of two functions g and h, where g must be only a function of x and h must be only a function of y. Then only we can apply the variable separable method. But in our case, this is not true, so we cannot go ahead and apply the variable separation method. For this, we will have to make a substitution. Let y over x equals to v. If we do the substitution, then our differential equation can be reduced to a variable separable form. So let's do that. We have y over x equals to v, which can be also expressed as y equals to v times x. And when we take the derivative of both sides with respect to x, this will be equals to v plus x times dv over dx. Right. Our differential equation can, before doing the substitution, what we have to do is substitute y over x with v and dy over dx with this new transformation. We will rewrite our function as dy over dx. What we'll do, we'll divide both the numerator and the denominator with x squared, such that we have 1 minus 3 times y over x plus 2 times y squared over x squared whole divided by 2 times we have xy, so divided by x squared will give us y over x minus 1. Now we will make the substitution. So in place of dy over dx, we have v plus x times dv over dx equals to 1 minus 3v plus 2v squared divided by 2v minus 1. Next, we will subtract v from both sides. This will give us x dv over dx on the left hand side, and combining these two terms on the right hand side, we will get 1 minus 2v divided by 2v minus 1. And this will be cancelling out, leaving us with negative 1. That means we now are left with x dv over dx equals to negative 1. Separating the differentials, we will get dv equals to negative dx over x. Now what we have done, we have successfully reduced our given differential equation to a variable separable form. So let's integrate both sides. The integration of dv fairly straightforward. That will be v equals to negative dx over x, so that's negative log x plus the constant of integration c. Now we'll finally replace v with y over x, so that will be y over x plus log of x equals to, this will be absolute value of x, equals to the constant of integration c. So this is going to be the solution to our given differential equation.